All the textbooks about the beginning of the universe say that the dwarf planet Pluto is the furthest object in our solar system. Hundreds of thousands of minor icy planets and asteroids populate this region of space within the Kuiper Belt. Once thought to be the ninth planet in our solar system, Pluto was named after Pluto, the Roman god of the underworld. However, Pluto lost this standing in 2006. According to current scientific theories, the solar system contains innumerable asteroids, a small number of dwarf planets, and just 8 planets. Our knowledge of the universe has expanded greatly over the past several centuries, and we now have a good idea of how planets operate, what they're made of, and whether or not they may house humanity in the far future. But perhaps there is still a great deal to discover about the stars in our own galaxy. What mysteries has the James Webb Space Telescope finally solved about Pluto? Does it harbor life, either known or unknown? And does it have an interior ocean? Join us as we explore the incredible mystery of what the James Webb Space Telescope discovered on Pluto that was hidden all along. The ninth planet, Pluto, was much admired for 76 years. No one noticed that it had the smallest moon in the solar system. The fact that its orbit was skewed and oval didn't bother anyone. Pluto was a bit of an oddball, but it was our oddball. Kids can relate to it because it's miniature, and many adults can identify with its plight as an outcast. The populace felt compelled to defend Pluto. That there was a public outrage when Pluto was reclassified as a minor planet 15 years ago is perhaps not surprising. The IU revised their definition of planet, and Pluto was left off the list. According to the revised criteria, a planet must possess 3 characteristics. It has to go around the sun. It needs to be massive enough that its own gravity can shape it into a sphere or something near one. And it must have removed any debris from its orbit. Pluto failed the third and final evaluation, so we have a dwarf planet. The term planet has been used in a much broader sense for millennia. In the 1600s, when Galileo trained his telescope on Jupiter, everyone thought any big orbiting object in the sky was a planet. Even moons counted. When astronomers first discovered the rocky rocks we now refer to as asteroids in the 1800s, they also referred to them as planets. From the start, Pluto was considered to be a planet. It was initially seen in January 1930 by amateur astronomer Clyde Tombaugh using photographs obtained using a telescope. A current employee at the Lowell Observatory in Flagstaff, Arizona, was where we found him. Tombaugh reported his finding immediately to the observatory's head. "I have found your planet X," he boasted. Tombaugh was alluding to a hypothetical ninth planet that would orbit the sun beyond Neptune. However, things took a strange turn when it was discovered that Pluto wasn't alone in the universe. Beyond Pluto's orbit in 1992 was an object only a tenth as wide. Since then, almost 2,000 frozen bodies have been discovered in the Kuiper Belt, the coldest region of the solar system's outskirts. There could be a great deal more to come. Questions were raised when it was discovered that Pluto had so many neighbors. What did these unfamiliar planets have in common with Earth? Why did they stand out? Suddenly, astronomers were confused about what constituted a planet. Professor Mike Brown studies the planets as a planetary scientist at Caltech in Pasadena. He discovered the first Kuiper Belt object visible at the time that seemed to be larger than Pluto in 2005. In commemoration of the television show Xena, Warrior Princess, its name was changed to Xena. This icy remnant was created when the sun and planets were very young. Brown suggested that Xena should be the 10th planet if Pluto was the 9th. However, if Xena didn't merit the status of a planet, then neither does Pluto. In 2006, disagreements over where to place Pluto and Xena reached a boiling point. The action culminated at a conference of the International Astronomical Union in Prague. After extensive discussion, a revised definition of planet was offered for a vote on the last day of the August meeting. Dwarf planet status was awarded to Pluto and Xena. Eris, the Greek goddess of strife, is now known as Xena, given its importance in shaking up our understanding of the solar system. The name is apartment. Since Brown's work contributed to dethroning Pluto as a planet, he has earned the Twitter handle @PlutoKiller. Posters and textbooks were reproduced and updated immediately. However, many planetary scientists have never updated their methods, and this is especially true of those who focus on Pluto. That could be sarcasm or malice on their part, But Metzger and others argue in two papers that there are also valid reasons to reject the IU's definition of planet. The scholars read numerous books, articles, and letters to compile this information. Some of the papers were centuries old. They illustrate the multiple incarnations through which the term planet has been used by scientists and the general public, and the reasons were not always obvious. Ceres is an example. Between Mars and Jupiter in the asteroid belt is where you'll find this thing. After its discovery in 1801, Ceres was given planet status alongside Pluto. As more objects were discovered in the asteroid belt, Ceres was claimed to have lost its planet status. Scientists had determined that Ceres had hundreds of neighbors by the end of the 1800s. According to the legend, Ceres lost its planetary status because it was no longer noticeable. That's how Ceres and Pluto were similarly afflicted. Right, Metzger's group now asserts that this is not the true story. Even until the 20th century, Ceres and other asteroids were still regarded as planets, albeit minor planets. Science Newsletter reported in 1951 that thousands of planets are known to circle our sun, with the caveat that the vast majority of these planets were small fry, with sizes ranging from that of a city block to that of the state of Pennsylvania. It wasn't until the 1960s that minor planets became a derogatory term. They were observed by spacecraft for the first time. At that point, planetary appearances were still present in the biggest asteroids. However, the majority of the smaller ones were abnormal lumps. This proved they weren't just smaller versions of the larger spherical planets. The fact that asteroids often fail to escape their orbits is irrelevant to the decision to rebrand them. What about moons, you ask? Until the 1920s, they were referred to as planets or secondary planets by scientists. It's surprising that despite scientific evidence to the contrary, the common practice of referring to moons as planets persists. Non-scientific media, such as astrological almanacs, were largely responsible for the shift. Horoscopes in these tomes are derived from the planetary alignments. Astrologers insisted that keeping the number of planets in the sky small was easier to understand. Later, though, fresh information gleaned through space exploration reintroduced moons to the planetary family, at least for some huge spherical ones. Including moons, the term planet was employed again in scholarly publications starting in the 1960s. The International Astronomical Union's definition of planet is, in short, not the first. The word has gone through numerous definition shifts, therefore, it might be altered once more if necessary. The IU definition is often defended on the grounds that it prevents the number of planets from getting out of hand. What would your life be like if the universe contained hundreds or thousands of planets? How could the common person possibly remember them all? Exactly what would we put on the lunch bags? In contrast, mere worries that focusing on only 8 planets will discourage people from learning more about the cosmos. Perhaps in the end, the definition of a planet is subjective. In 2015, when NASA's New Horizons probe flew by Pluto, it revealed a planet with a lot more activity than anyone had expected. Nitrogen cliffs, reminiscent of Norway's rough shoreline, and methane ice shards as tall as buildings can be found on the dwarf planet. The Earth is scarred by fissures deeper than the Grand Canyon, and frozen volcanoes tower higher than the Himalayas. The cameras on board the spaceship photographed a massive heart-shaped feature on the faraway globe, which made millions of fans on Earth swoon. 8 years have passed since scientists caught that first breathless sight, yet they are still seeing the world through fresh eyes. Since New Horizons was traveling at 32,300 miles per hour when it made its closest approach to the dwarf planet, it was only able to take detailed pictures of the side of Pluto that was facing the sun. One of them was momentarily hidden from view by the darkness. Now that scientists have analyzed the close-ups of the near side, taken by the spacecraft days before it zipped past, they are starting to look at the images of the other half. Scientists refer to such a region as the far side or the dark side. Despite the low resolutions, the photographs clearly depict the landscape with detail down to about 1 mile. That's at most 250 times more detailed than images captured by the Hubble Space Telescope, which orbits the Earth. Scientists now have a new perspective on this dynamic world thanks to the analysis of hundreds of images shedding light on questions such as whether or not an ocean lies beneath the icy crust and how compounds freeze out of the atmosphere to shape the planet's surface. The statistics even lend credence to the idea that the cold world could support life. However, there are mysteries presented by the pictures. For instance, the ice fragments that resemble skyscrapers were just recently discovered on Pluto's far side, yet they now appear to orbit the planet. Because of this, their beginnings are among the dwarf planet's greatest mysteries. Richard Binzel, a planetary scientist at the Massachusetts Institute of Technology in Cambridge and a New Horizons co-investigator, says, Pluto is the gift that keeps on giving. Then, in 1996, scientists were able to see surface details at a resolution of 310 miles thanks to the Hubble Space Telescope. The photographs were blurry, but they showed a planet-like globe with higher global contrast than any other planet in the solar system, including Earth. In July 2015, New Horizons famously observed a heart-shaped feature just north of the near-side's equator, confirming that Pluto is indeed a dynamic world. Sputnik Planitia, a frozen basin roiling and flowing with enormous glaciers, is located within Pluto's left ventricle and is now known to have a profound impact on the planet's dynamics. Pulses of sublimating ice rise into the air as the sun warms the frozen plain, only to fall again when night falls. It's possible that the beating of the heart tipped Pluto over. Francis Nimmo, a planetary scientist at the University of California, Santa Cruz, and his colleagues noticed something odd about Sputnik Planitia not long after the first photographs of Pluto's near side were sent to Earth. It is situated almost perfectly opposite Pluto's largest moon, Charon. The chance of an accident occurring is 5% at most. Instead, simulations show that a subterranean sea began to rise into the rift just as the basin was forming. Nitrogen gas from Pluto's atmosphere condensed and froze in the icy crater. Pluto's current alignment is the result of a huge burden caused by the accumulation of additional water and ice. The concept of an ocean beneath the surface is not new, but the far side photos have provided significant support for this theory. Some of the most convincing evidence comes from chaotic terrain, a confusing patchwork of hills, fissures, and plains located on Pluto's opposite side from Sputnik Planitia. Scientists believe that an asteroid or comet impact caused seismic waves to rip through and around Mars, Mercury, and Europa, one of Jupiter's moons. When these earthquakes finally collided on the opposite horizon, they tore the surface in ways similar to what we see on Pluto's icy moon, Charon. Planetary scientist Oliver White from the SETI Institute in Mountain View, California, who did not participate in the study but did create a geologic map of the far side, contends that the feature does seem to mimic ones observed elsewhere in the solar system, but that the resolution in the image is low. A majority of other scientists share this opinion. Perhaps we won't know unless we make a return trip. The discovery of numerous fractures on Pluto's far side, among other geological peculiarities, lends credence to the idea of a subsurface ocean and may even provide insight into the planet's formation. For a long time, scientists have speculated that Pluto's ocean had a cold start, meaning that it was frozen at the time the dwarf planet was formed. Eventually, the radioactive decay in its rocky core would have produced enough heat to dissolve it. The ice would have shrunk as it melted, causing ripples on the surface, adds Nimmo, much like the wrinkling of an apple after being stored in the fridge. This expansion of the ice as it refroze would have led to surface cracking. If this is the case, then Pluto's surface should appear wrinkled and cracked in photographs taken recently. However, New Horizons only captured images of fissures, indicating that the dwarf planet's ocean was once liquid but has now frozen partially. For instance, photos of Pluto's far side show a huge crack that runs the length of the planet's near side. It has progressed to the point that it wraps around the entire dwarf planet from the North Pole to the South Pole on the opposite side. Like the East African Rift System, which divides that continent in two, this one also divides landmasses. Pluto's rift, in contrast to Earth's, is likely a scar from the freezing and ever-expanding ocean rather than evidence of moving continents. The age of the fissure indicates that the liquid ocean instantly began to cool after it was exposed to the air. If this is the case, marine life could flourish there. The crimson color of the water, which suggests that it is stained with organic molecules, was observed in samples that had likely poured out of the ocean on the near side. The complex organic matter with a reddish-brown color has been created in the lab by radiation akin to solar wind or cosmic rays. Therefore, it is feasible that this could happen in a world like Pluto. In addition, ammonia allows the formation of molecules necessary for life, such as the bases found in RNA and DNA. Red ammonium-laced ice on Pluto's near side is an important indicator that the dwarf planet may be rich in organic compounds. The notion, which has acquired a lot of support among planetary scientists, does not imply that life originated on Pluto, but rather that it could survive if given to the planet. The far side measurements have done more than only aid in the search for life on Pluto. They have also spawned a number of riddles. Scientists were surprised to see ice chunks the size of skyscrapers in the easternmost part of the near side in the initial photographs sent back from the James Webb telescope, occasionally reaching heights of 1 mile, approximately 3 times the height of the Empire State Building in New York City. These ridges are equally distributed and rise sharp and knife-like into the sky. They may reach a length of 19 miles. It would be a nightmare to try to get about in this area until researchers discovered what lay on the other side of the planet. However, they remained a mere blip. The current map is hazy, but it's easy to make out that the bladed topography continues around the entire periphery, reappearing on the western edge of the near side. They are one of Pluto's major mysteries since they span a region on the far side that is 3 times as huge as their extent on the near side. On highlands and plateaus, spectral measurements show that the blades are made of methane ice, forming a belt around the equator. However, nobody knows for sure how they originate. It's possible that, like frost on Earth, methane in the atmosphere solidified and fell to the Earth. Maybe they're the remains of a coating of methane ice that the intense sunshine has worn away. The sharp ridges have inspired some experts to consider the second possibility, as they are similar to structures that emerge in the high Andes, albeit on a much smaller scale. The penitents of South America are merely a few meters in height and develop in mountainous areas. Light is thought to have a role in the formation of penitents since they face the sun and grow near the equator where solar radiation is most intense. Sublimation, the process that supposedly carves down troughs between ridges like blades, is said to be driven by sunlight. One thing is certain. Understanding the icy fragments in Pluto's terrain more generally requires a deep dive into the dwarf planet's climate. The history of Pluto is emblematic of humanity's never-ending quest for knowledge and the dynamic nature of our understanding of the cosmos. Meanwhile, researchers will improve existing climate models to better reflect observed phenomena. They want to attempt to recreate the conditions of Pluto's atmosphere and possible ocean in a laboratory. The James Webb Space Telescope will be aimed more directly at the minor planet. Webb cannot take high-resolution images of Pluto, but it can use longer wavelengths and is hence more likely to find something unexpected. Now we're left wondering if Pluto will ever respond to our age-old question. Are we alone? Thanks for watching another episode of Voyager. While you're still here, make sure to click the video on your screen for more mind-blowing videos about space.